Welcome to today's webinar, RTK on your smartphone or tablet, brought to you by GPS World Magazine and our sponsor, NavCom. I'm Joelle Harms from North Coast Media, digital producer for GPS World Magazine, and I will be your event manager. Before we get started, I want to let you know that today's webinar will be recorded. You are now currently in a listen-only mode. The recording will be available 2 weeks from today on our website, gpsworld.net/webinars. A link to the on-demand recording will also be emailed to you when it is available. At this time, I'd like to acquaint you with the ways you can participate during today's presentation. Please notice the Submit button in the lower left-hand corner of your console. We encourage you to ask questions throughout the presentation. Just type in the text box at the bottom left, then click Submit to place your question in queue. Questions that were submitted during registration may be covered in this webinar. Some questions may also be answered in an upcoming issue of GPS World Magazine or in our e-newsletters. We strive to answer as many of your questions as possible. Finally, if you experience any technical difficulties during today's event, select Help to submit your issue, and assistant producer Bethany Chambers or I will personally assist you. Now I'd like to turn today's event over to our moderator, Managing Editor of GPS World Magazine and Geospatial Solutions, Tracy Cosman.
Thanks, Joelle, and hello, everyone. Welcome to another GPS World webinar. This one's sponsored by NavCom. We're here to talk about RTK on your smartphone or tablet. I'd like to introduce you to our speaker, Eric Gackstatter. Eric is GPS World's contributing editor of the popular Survey Scene e-newsletter. He is also editor of our monthly Geospatial Solutions newsletter, which has its own website at geospatialsolutions.com. Eric has spent more than 20 years in the GPS survey and mapping industry as a product manager, GPS user, consultant, and a nonpartisan advocate for the GPS user community. Eric, take it away.
Hey, thanks, Tracy. Hey, great to be here today talking about this subject, which I've spent a lot of time on in the last probably 18 months. If you were with us a couple, 3 weeks ago, we did a webinar, actually the first live webinar we've ever done down at the ESRI conference in San Diego. There was 14,000 GIS and survey folks down in San Diego, and it was really neat the way we had it set up. We had a sort of a plexiglass podcast booth. It was 12 by 15 feet. Several people inside it, had a guest speaker in there off the show floor, and talked about this same issue. And you know, it's kind of a hard issue to cover in just one webinar or just one article. And if you look back at my GPS World Survey Scene newsletters over the past 6 months, I've written quite a bit about this, my experiences with smartphones with RTK and tablets with RTK, and it's really been a fun exercise because I mean, historically, if you look back at RTK over the last, I don't know, 20 years or so, I guess, the solutions have typically been, you know, generally proprietary solutions that, you know, like the receiver manufacturer would provide their data collector and their radios or sometimes third-party radios for the communications, and it's really been a sort of a dedicated from one supplier type of solution. But since, you know, especially since iPhone and iPad have been introduced, and those sort of were the catalyst to for this explosion of new tablets and smartphones in this era, and that started in 2009, I think. The iPhone was earlier than that, but yeah, over the last 5 years, this whole mobile device market has exploded. Just a tremendous number of mobile devices available, tablets and smartphones that have tremendous capabilities now. In fact, when I was down at the ESRI conference, I had a Galaxy 3 smartphone, and it ended up dying on me the last day, and came back home and got a Galaxy 5 the next day, and the screen is just tremendous on this. I mean, I'm thinking back to the data collectors I used to use with RTK, you know, even a few years ago, and this screen just blows them away, you know, the graphics capability and the power of it. And so it only makes sense that people are talking about and have been talking about, how do I use my existing mobile phone, or smartphone, or tablets, consumer type tablets, for high precision GIS or even surveying. And so again, I've spent a lot of time on this over the 18 months, just playing around with different scenarios. I have a consulting business, and I've deployed several of interesting systems that use different kind of tablets, and not really any smartphone deployments yet, but boy, I see it coming pretty soon, just because there's just so many of them out there. So what I'd like to do today, and sort of what we missed out on this last webinar I did down at the ESRI conference, is I really didn't get into the nuts and bolts of the components and how I put these systems together sometimes, and these are just some examples of what I've done, and there's a lot of ways to skin the cat, and so this isn't the only way, but I just thought I'd share the different components that you'll need. So I figured first we'd cover a little bit about what RTK is, for those of you who aren't familiar with it, and then what components are required for using RTK, and thirdly, where can you find an RTK base? Because traditionally, and I used to do this a lot, whenever I'd go on a project, let's say even 8 years ago, I would have this big Pelican case I'd pack up with a base and a rover and some radios, and I could take that anywhere in the world and be able to use RTK. But setting up the base is always a pain, and if you wanted to tie it into an existing horizontal datum instead of assuming coordinates, that was always a pain dealing with that. These days, there's so many RTK bases out there that are publicly available, some subscription-based, some fee-based, but nevertheless, there's lots of RTK bases out there that you can tie into, so you don't have to deal with that part of it. You can just pull up to your job site, pull out your rover, and start it up and get your internet connection going, and you're golden. All of a sudden you're 1 to 2 centimeter accuracy within just a few minutes, and so it makes it a lot easier than it used to be. And there's lots of them out there. You don't have to make the capital expense of purchasing a base station or operating it, maintaining it, and that sort of thing. So we'll talk about that a little bit. What RTK bases are available out there. And I'll touch on which smartphones and tablets can you use with RTK, because there's just tons of smartphones and tablets out there now. I mean, it just seems like every week somebody's introducing a new tablet and a new smartphone too, with different operating system, different capabilities and features, and we need to touch on that a little bit to see or to understand which ones are compatible or more compatible with RTK, at least at this point in time. And then lastly, some audience Q&A. Just like at the ESRI conference, we had tons and tons of pre-registration questions and questions during the webinar. I put out a newsletter shortly after that answered only probably a handful of those. But we got a ton of questions for this webinar too, and so I'll touch on those also. We've got a list of them for pre-registration questions that are really neat and relevant, I think, to most of you, and then maybe touch on some live questions also. So first one is, what is RTK? Well, for those of you who aren't familiar with it, it's just a technique used by a GNSS receiver to provide 1 centimeter real-time precision. And I say 1 centimeter, that's kind of loosely. I mean, a lot of folks will say 1 to 2 centimeter or 1 centimeter plus 1 ppm, so which has to do with the distance you are from the base station. But essentially, that's probably the simplest way to remember it. It's 1 centimeter, and the key is real-time precision. That means you get it out in the field. You don't have to come back to the office to do any post-processing or anything like that. You get the solution right in the field. So and RTK takes some amount of initialization time. So when you first turn it on, it's got to resolve ambiguities, and I won't get into that much, but basically it's initialization time that takes time in order to get to that 1 centimeter positioning. And the reason I say satellite tracking in there is because it takes, the more satellites the better for RTK, and really you want a minimum of 6 satellites that you're tracking. And this becomes an issue when you want to start using this kind of technology in not so friendly GPS environments. For example, I work with a lot of agricultural companies and utility companies. And in ag, it's not so much of an issue because you're typically in wide open fields, and so you have a a clear view of the sky. But with utility companies, and forestry companies and environmental companies that I've worked with also, they're typically in these environments where there's lots of trees and potentially lots of buildings around, and all those objects block satellite signals. And there's only so many up in orbit that are broadcasting at the moment. At any one time, there's maybe 20 max between GPS and the Russian GLONASS satellites, and then if you start to chip away at that with blockage, you may get down to 10 or even less than that, depending on the environment. And it just makes it much tougher for that initialization time to be practical. So those two things, it makes it a challenge sometimes to use RTK in sort of challenging environments. And it frustrates users sometimes because lots of users don't understand that that's the issue. If you go out in a parking lot somewhere, you're going to get an RTK fix down to centimeter solution in seconds or tens of seconds. Whereas if you're underneath trees trying to shoot a fire hydrant or a manhole or something like that, and you've got buildings around you, it can be an impractical technology for that kind of environment. And there really is no rule of thumb to that, except that you need to have at least 6 solid satellites that you're tracking to get reliable RTK. And then the third thing, this third item on this list is, or on this slide, is the data connection to an RTK base station. That is really, really critical. You need to have a reliable data connection. It doesn't have to be a high bandwidth data connection. It doesn't take a lot of data, but it's got to be really, really reliable. And just like 10 or 15 years ago, when people would talk to me about, hey, my RTK is not working, the thing I always point to is the communications, and that's always been the issue that I've seen. That's the first thing I ask folks about. And it's no different today. The difference is, 10 to 15 years ago, we were using either 900 megahertz radios or UHF radios, and some people still do today. And those can be interrupted. They can be interfered with by other UHF users in the area. Especially, I remember being in some metro areas using my UHF radios, and if someone else is nearby and it's interfering, that'll cause your RTK link to go down, and then you can't work until you can again bring that connection back up and have it as a reliable connection. So that's really key. Is you got to have a solid internet data connection. And today it's in metro areas, it's pretty reasonable to have that with mobile phones or data plans, Verizon, AT&T, and so on. But you still, even in metro areas, you find dead spots, and it's even, of course, more challenging out in rural areas, especially when you think about farming, RTK users in farming. That's why a lot of them still use 900 megahertz radios or even UHF. But anyway, the point there is that data connection is, if you don't have that, then you're going to be super frustrated with RTK, because you got to have a solid internet connection or data communication in general. And so RTK is used mostly with L1 and L2 receivers, which are commonly referred to as dual frequency receivers. It used to be GPS only, but nowadays a lot of them are GPS and the Russian GLONASS system, because it adds more satellites. And if we go back up to number 2 on this list, the more satellites, the better, sort of thing. But you can find sort of lower performing, lower cost L1 RTK receivers, and I played around with those 5 or 6 years ago when Magellan, which is now named Ashtec, came out with a L1 based RTK system. And there's several of them out there now, but the challenge with those is the initialization times are typically much longer, and that may be okay in agriculture or some areas where you have an open view of the sky. But when you get into areas where you lose initialization, maybe several times a day or even several times an hour, I'm having to wait 3 or 4 or 5 minutes to get your the fixed solution back for centimeter accuracy. Is just too long. And so L1 RTK is viable in some applications, but you got to be careful to make sure it really fits that particular application. I guess the value is that companies market their L1 RTK systems as a much cheaper alternative to L1/L2 receivers. And next slide is RTK Components. So what do you need to put together an RTK system? You need these pieces and services here. You need first of all, you need an RTK capable GNSS receiver, and it's not the GNSS receiver inside the smartphone or the tablet. And a few months ago, back in April, I published an article where I showed where I was using RTK inside in AutoCAD, and I had AutoCAD running on a Samsung Galaxy Note tablet/smartphone. And I didn't give a clear enough picture, I don't think, of the system. That's why part of the reason I want to really make this specific today is that people were saying, hey, how are you getting RTK using the GNSS chip inside the Galaxy Note? And the answer is I wasn't. I was actually Bluetoothed to a GNSS RTK receiver. I call it a small brick. I was Bluetoothed to that, and that was the RTK engine I was using, and the antenna too. So I wasn't using any of the GNSS features inside of the smartphone. I was purely using the smartphone as a data collector running AutoCAD and as a communications device to the internet because it had a 4G plan on it. And so I was using that to talk to the RTK base. So you still there is no RTK solution today where the GNSS chip is inside the smartphone or the tablet. They're all external receivers, either cabled or Bluetooth or Wi-Fi or some kind of communication between the mobile device and the RTK receiver itself. Now, that sort of begs the question from folks, and I think it's one of the questions that that was submitted to us is, hey, when will RTK receivers be integrated inside of mobile phones or tablets? And I guess the easy answer is it's coming. The tougher answer is when. And I'll go back to a statement made I think a couple of years ago at the GPS World Dinner at the ION conference. It's sort of the techie conference for GNSS receiver folks. And down there was a professor out of University of Texas at Austin, Todd Humphreys, who predicted that we'd see RTK in mobile devices by the year 2020, which is only 6 years away. And then further on that topic, I've spoken to some of the designers of chipsets that are built inside of smartphones and tablets, and they say actually that the chipsets are capable of RTK. The weak link actually is the antennas. Because the mobile phone folks and even the tablet folks, they allocate very little expense and real estate for antennas inside these devices, and so many times it just ends up being a trace on a PC board, which is super low quality, and so it makes it really tough for a receiver to be able to do RTK type of operations with that kind of antenna. But I think eventually, or not eventually, I think what you'll see before that is you'll see what I call RTK pucks, which are small devices, maybe the size of a silver dollar, that will have a battery, a Bluetooth chip in them, a GNSS receiver, and an antenna. And I think you'll see those, and you'll be able to Bluetooth to them from your smartphone. And I think over the next 2 or 3 years, you're going to start seeing quite a few of those. And I think you'll see the prices on RTK receivers drop quite a bit. And I'll talk about, there's an audience question about that that was submitted beforehand, and I'll talk about that a bit too. So the second thing on the list here is you'll need some kind of mobile device. And in this case, we'll talk about smartphones and tablets because that's the focus of this topic. But you could also use an industrial handheld or even a notebook computer. My focus here was to talk about using devices that are already in your hands or inexpensively acquired. A consumer type of tablet like a Galaxy Nexus 7, it's only $200 or $250, and I know people using those today for RTK operations. Thirdly, you need some kind of data collection software, and that ends up being a really important question or a really important subject, and I'll talk about that further here a little bit later. And you need some kind of NTRIP software utility. the purpose of this software is to manage the connection to the RTK base. Okay, so there's RTK networks out there. There's single base RTK bases. You need some piece of utility software to manage the connection. You know, you have the IP address, the port number, password, login. You need some kind of software utility to manage that connection. Some manufacturers of data collection software build that utility inside their software, but most of them don't. But there are third-party pieces of software you can use to enable you to be able to use apps that don't have that capability built inside. And of course, you need access to an RTK base. I've written quite a few articles. I wrote one back in, I think it was April or March, that listed all the publicly available RTK bases in the U.S. on a state-by-state basis. I didn't list all the commercial ones yet, but I intend on doing that because there's lots of commercial ones out there too. And then I didn't list any outside of the U.S. just because I don't have a good list of them. So I invite and ask for anybody who's aware of RTK networks or RTK bases that are available to the public in countries outside the U.S. You know, please email me and I'll publish them for everybody to benefit from. And then lastly, we need a wireless data connection to the RTK base. And again, it's you know, historically or classically, it's been a dedicated communications link like UHF radios or 900 megahertz radios. But these days, with the proliferation of wireless system mobile phones and, you know, the expansion of mobile phone networks, is that more and more people are trying to use and can use their mobile phone networks as a way of access, as a wireless data connection to access RTK bases. And then you don't have, you know, issues, you know, the line of sight issues you run into with UHF and 900 megahertz radios. You do have some other issues that are introduced, but certainly a lot of folks are moving towards using mobile phone networks as the wireless data connection. So this next slide just shows a picture of what I'm talking about, all these pieces in here. So that's a picture on the right of my new Galaxy 5 phone. It's just running Esri's collector. I just brought up a sample screen of it to give you an idea. So that's on the right side, and again, on that device, there'd be some kind of NTRIP utility, which they're available out there. And if you go to the Google Play Store, there's at least one I know of, maybe a couple of them. And then Bluetooth to a RTK GNSS receiver, and then an antenna. So these are all the hardware components that you need. So the wireless network of the mobile phone that would access the RTK base at another location, right? Could be 5 miles away, 10 miles away. And this is the hardware you would need to take in the field, is a receiver, an antenna, and the mobile phone. And there's, as far as the receiver goes, there's different flavors out there. This is just one I had handy. I took a picture of yesterday. But there's others out there. Some have integrated antennas inside the receiver, so it's not a separate device. And there's several manufacturers out there. Actually, the RTK receiver part of this is not really the important part. That's not the holdup, because there's lots of choices there. It's more, okay, on the mobile device side, you know, what app software are you using to collect the data, what NTRIP utilities do you have, and where's the closest or the most convenient RTK base that you can access. Those are the more burning issues rather than the receiver itself. And I also took a picture on this next slide of an iPad, and it's actually running, I know you can't read on there, but it's running an NTRIP utility. And what you see there, you can't read them, I understand that, but is a list of base stations. And this is actually, when I was at the Esri conference 3 weeks ago down in San Diego, there was a free RTK base down there about 5 miles away from the convention center. And so we logged on to the California reference network. There's a California, a free one actually, for the first subscription. You can access up to 330 bases throughout California. And this is what you see on the iPad screen, is a list of the RTK bases down the Southern California area. And we just used one of those down there, and we were able to get RTK on the iPad And it was fixing with, we were only 5 miles away from the base, and so it was fixing just in a matter of seconds. So here's the first poll question, and I like to do these because it gives me an idea what the audience is, what you guys are thinking, and then, you know, even amongst yourselves, you can sort of understand what other people are thinking. So if you don't mind, just a basic question to start off here. What's your involvement with RTK? I'm just trying to get an idea. First answer is I use RTK technology now. I want to start using RTK technology next few months or imminent. You know, you want to get into it. You know you need to get into it. You're just trying to figure out how. And then thirdly is just, hey, I just want to learn more about it because I need it in the future sometime. So if you don't mind, just pick one of those answers. So what I'll do is we'll display the results of the poll here in a few seconds, and then the final numbers I'll actually publish in my next newsletter. So again, you get some idea of what you're thinking. I get some idea of what you're thinking, and understand people's attitudes on this. Joelle, you want to go ahead and display the results of the poll so far? And this is sort of just a snapshot over the last 20, 30 seconds or so. So that's good. So 65% using it now, 12.5, 13 want to use it next few months, and 23 are trying to figure out somehow in the future, maybe. So that's good. So what my guess is that these will be pretty similar numbers as a final poll. But go ahead, and if you haven't done it yet, please go ahead and answer. And again, I'll publish the final polls or poll results in my my next newsletter. So this next slide has to do with mobile devices, and this is really the crux. This comes down to the crux of the matter. That's what makes it probably the most challenging with using RTK and different mobile devices these days. Is you think about it, 10 years ago, probably even 5 years ago, 5, 6 years ago, and I was in the same boat. Is back then, we were using either for data collectors. For our RTK systems, we were either using manufacturer-specific data collectors that the manufacturers would make themselves, or they'd buy from somebody and supply to you, or you would use an off-the-shelf sort of Windows mobile device, right? Like remember the old TDS, Recon, or Nomad, or Juniper Systems, Allegro, or some data collector like that. But these days, ever since, probably about 2009, 5 years ago, when the iPad was introduced, and then all these other mobile devices started to come along, and Android really took off, the iOS devices took off, and then all of a sudden, people have these powerful devices in their hands, these Android or iOS devices, or even Windows to some extent, and they're saying, hey, how can I use these with RTK? And a lot of my clients that I deal with are asking me this. Hey, how can I integrate my iPhone or my iPad or my Galaxy Note or whatever non-Windows device into RTK? And really, you can summarize the challenge sort of with these three areas, I guess. You have Android, which is sort of the dominant operating system for smartphones and tablets these days. I mean, you look at the market share numbers, and they're just growing like crazy, and they're far more Android devices. It's an open source operating system, and so that makes it really attractive for device manufacturers to integrate that into their systems. The challenge sort of there is that since it's open source, you can tweak it, and so each manufacturer, in theory, could tweak it to fit on their receiver or on their mobile device. And so software written for Android may not necessarily run consistently across all platforms because it's really kind of wide open. The iPhone, the iPad, totally different software development environment, but much more controlled. And so if software is written for an iPad, it's going to run on all the iPads the same way. And then you have, those two have really overtaken, iOS and Android, have really overtaken and blown away the Microsoft Windows stuff by far on mobile devices. I mean, it's just, there's no comparison today. You still see Windows Mobile and Windows Embedded Handheld on some sort of higher-end professional devices, but you don't see that operating system anywhere on consumer devices. You do see Windows 8 and Phone 8 on some phones these days, but if you look at the market share numbers, and the Microsoft market share is something like 3% or 4%, or I mean, just almost negligible. So the primary ones that I've tended to focus on are the ones that people have, and those are Android-based devices and iOS-based devices. And I've written a few articles called Operating System Wars, Windows, Android, iOS, and why does it matter? And that's where this is really an important point, is it matters because the application software that you want to use has to be written for the operating system that your device is running. For example, Esri's got this product called ArtPad. It's a data collection program. It's written only for Windows devices. So you can run on a Windows tablet, a Windows notebook, or a Windows handheld. Doesn't run on Android, doesn't run on iOS. So they have no solution for that, at least for ArtPad, for Android and iOS. Now they have some other products, Collector and so on, but they have different capabilities and certainly some better and some not so good. So you just can't, if you're a user, an enterprise user, even as a single user of ArtPad, and you want to use it on your iPad that you bought last month, it doesn't work. It doesn't happen. So what's happened over the past few years is some people have migrated some of their products from Windows to iOS and Android, but a lot of them haven't. I mean, because it's an expensive venture. I mean, you need the same programmer likely is not going to be proficient in Windows, Android, and iOS. So you end up having to have bigger software teams to handle it. And if you're just a small software company, they have a difficult time keeping up. And so what you're seeing today is a lot of different kinds of data collection software becoming available for Android and iOS that you've maybe never heard of before, and and a lot of cloud-based kind of services too, where it's not just a standalone piece of software like ServCE or ArtPad or TerraSync or those kinds of data collection software products. They're actually cloud-based, where you have to you have to pay for a subscription service. And you get an app on your iPhone or your Android device, and the server operated by the vendor is the one that you end up uploading your data to and publishing maps and that sort of thing. So the operating system matters a lot, and I think I have some other discussion here too about a little bit more about that. So when you go to select a mobile device for RTK, what do you need to look for? Well, sort of one of the first ones is smartphone or tablet. But I started thinking about this after I wrote this slide. It doesn't matter that much, because some people want to use them for both. For example, I know some users who they may want to use an iPhone or an Android smartphone just to do some recon work with RTK, or do some spot checking for consultants or some contractors. They want to check their work and so on. Just want to pick up a quick, easy to handle smartphone and go out and do work there. Or the next day, you may want to connect it to a tablet, an iPad or a Panasonic ToughPad or a Dell Venue or something like that, and be able to do work that way. Now, the neat part about it is the GNSS receiver, it doesn't care. Remember, it's typically a Bluetooth type of connection to that, and so as long as the mobile device has a compatible Bluetooth chip in it to connect to it, and one day you can take out a tablet, the next day you can take out a smartphone or a notebook computer or whatever. So you can use that GNSS receiver for a lot of different activities, or even share it among departments. I've had folks mention that, hey, today I want, the surveyor is going to take it out and use it with ServCE on a Juniper system to Allegro, and then the next day someone's going to take it out on an iPhone with running Collector, ArcGIS Collector, or something like that. So that's you could use it with a smartphone and a tablet, not or a tablet. I mean, that's a better way to put it. So the outdoor readable screen is in different conditions is a really important thing to think about. If you can't read it outdoors, it's super frustrating. I read an announcement from Apple that they're going to introduce the next generation iPad is going to have a better outdoor readable screen, and that's what people want. And if you don't have that, especially if you're displaying maps out in the field, it's going to be a problem. Third thing is you need app software. There's actually NTRIP utilities for almost all platforms. There's free ones out there for Windows. There's I'm talking in terms of NTRIP utilities for Windows, Android, some for iOS. You need wireless data connection coverage. You think about battery life. How good's your how long do you want your batteries to last out in the field? On consumer devices, sometimes you're only good for 3 or 4 or 5 hours. You need to think about that. And then lastly, consumer versus industrial is, a lot of folks want to use inexpensive consumer type tablets and smartphones, and there's a lot to say for that, because the cost of industrial tablets especially can be up in that $3,000–4,000 range, and boy, you can buy a lot of Android tablets or iPads and you can break a couple of them and still come out ahead. But anyway, you need to make that decision, and I've got some more on that, but I'll probably end up putting that in my newsletter. So the next poll is, are there RTK bases in your area? And again, I published a list a while back. You can search through the old Survey Scene newsletters. It was earlier this year, about all the public available RTK bases in the U.S. on a state-by-state basis. But I'm just curious if you know of RTK bases that are available in your area. So go ahead and, again, just a straightforward poll here. Yes, not that I know of, or I don't know. And Joel, go ahead and display the results for me, please. Great. And the neat part about it is, boy, especially in the U.S. here, there's tons and tons of RTK bases available, and that list that I published in my article is just a partial list. There's commercial ones, and there's many more commercial ones, and others coming online too. And again, I'll publish the final poll results there. So again, we've sort of talked about data collection software so far, and so one of the key questions about data collection software is the workflow. For example, I know of several sort of Esri-based organizations that may have to use Esri products because it works in their, or it fits into their workflow. So they want to use ArcPad or ArcGIS Collector or something like that. So that's sort of a key consideration for data collection software, is how is it going to fit into your current workflow. And some folks are stuck with using specific vendors just because of that issue. And you have a changing landscape due to Android and iOS popularity. So like I was mentioning before, if you're going to use the ESRI, if you're in the ESRI world and you're used to using ArcPad, and all of a sudden you want to use Android or iOS devices, ArcPad functionality is not, it doesn't run on those devices, and so you have to look at other Esri products that fit that particular workflow. And like I mentioned before, thirdly here, many Windows and Windows Mobile data collection software packages haven't migrated to Android or iOS. And I'm just off the top of my head, I'm thinking of ServCE from Carlson. I mean, I don't think there's a iOS or Android sort of equivalent of that, although they may be working on it. I could say the same thing about Trimble TerraSync and gobs of other software out there that were built for Windows Mobile or Windows. They just haven't migrated those to Android and iOS yet. And then lastly here, there's a new breed of data collection software running across several platforms. Esri's Collector runs on Android and iOS. It's a pretty lightweight client piece of software now, but they're moving along trying to make it better. There's products like Fulcrum and Amigo Cloud that are, again, subscription-based cloud apps. You can use them in standalone mode, so you don't have to be connected all the time, but eventually it syncs up with the database in the back office. And just really quick here, this NTRIP DIP utility software I was talking about. So I figured I should define it, or at least spell out the acronym. So NTRIP stands for Networked Transport of RTCM via Internet Protocol. So RTCM is if you've heard of that, maybe it's a generic format. RTCM3 is the current version, but so typically when you log on or try to type into an RTK network, one of the formats they output invariably is RTCM3, and basically it's like same as ASCII, if you remember the old DOS world. ASCII was sort of a generic table that everybody used, a generic format everybody used and understood. RTCM is the same thing. It's a vendor independent format for using RTK, and so virtually any RTK receiver out there can read this format. And so as a result of that, almost all RTK networks will broadcast in an RTCM3 format in addition to other ones. So when you dial into a RTK network and are using NTRIP protocol, you get a menu selection of RTK base mount points, and I'll have a screen here that I'll show you in a minute. Then there's also a direct IP technology that you don't dial into a list of quote-unquote mount points or quote-unquote RTK. You don't have a choice. Basically, you dial into it, you give it an IP address and a port number, and you're going direct into the single base that you're targeting. And I've got an example here that I set up a system earlier this year. Again, some data collection softwares have NTRIP and DIP features built into it, but there's free and low-cost third-party NTRIP and DIP software utilities that are available that you may use with any location app software with RTK, even Google Maps for navigating if you want to. So there's free third-party out there and then low-cost third-party NTRIP and DIP apps out there, and I'll list them on my next newsletter about where you can see those. So here's an example of a screen. This is actually on an iPad. This is using a NTRIP app, utility app on the iPad for accessing an RTK base, and this is what I use down in San Diego. So the caster is actually the IP address for the RTK base, or the RTK vendor, I should say, even though it's a public organization. There's a port number on the right side, 2101. My login, Eric PG, and then there's a password. And then if you see in blue letters there, it says select mount point, and that's the screen I showed earlier. If you click on that, it would show you a huge list of base stations. I picked, in this case down in San Diego, I picked P475 RTCM3, and that's the base that was 5 miles away from the convention center. So just to give you an idea, and actually here's this next slide shows it. After I hit select mount point on the iPad, this is a partial screenshot of the list of base stations down there. So you just pick the one, in this case, that was closest to us, which was just 5 miles away or so. So here comes to the third poll. Which data collection software do you prefer to use? And again, just getting some idea of how tied into a certain workflow that you are. So first answer would be I've got to use data collection software that's compatible with our current workflow. And I guess it's kind of a loaded question. I was thinking more of an Esri environment or a Trimble environment or whatever environment, whatever workflow you're using out there. Some people are saying, hey, I've got to be compatible with ArcGIS Online or ArcGIS Server, and so therefore I've got to use ArcGIS clients. Or I guess there's other software out there that can be compatible with those services also. But I'm just trying to get an idea on how locked into the workflow you are, because this ends up being a really key question when you go to make a decision on how to deploy RTK out, in the field. This workflow has really a driving force there, because if you're not compatible, or if you're tied into a certain ecosystem or in a certain environment, then you're kind of stuck as far as what choices that you have. It's really interesting to me to see the results on this. I didn't know, and I'm glad to see that you're flexible, because the challenge with the first one is you kind of get tied into a certain workflow, and that limits your options for both mobile devices, for mobile devices. And again, I'll publish these final results of that poll. Thanks for that, Joel. So next subject is RTK Base Availability. And again, I'll reference back to the GPS World article that I published earlier this year, a list of public RTK bases. I'll provide a link to that in my fall newsletter to this webinar with a list. But there are tons of them out there, and the list grows. I think on a monthly basis. It gets broader and broader. There are subscription fees versus no subscription fees. So even some government agencies that provide RTK network services, some charge a fee and some don't. I mean, some are pretty nominal, some are relatively expensive. Some are several hundreds of dollars a year or one time. Some are absolutely free, and they're just justified by their own internal use of their survey departments. You have RTK networks versus single baseline. For example, up here, actually I'll show you an example out here in a second. I've got some slides on that. But there's RTK networks versus single baseline RTK, and I'll explain that in a second. Again, you need to have wireless data connection, and it's typically done by internet connectivity via a mobile phone or a MiFi device or a SIM card or somewhere along those lines. And then lastly, if you don't have access to a public RTK base, how can you set up your own? And I'll give you an example of what I did earlier this year when there was a case like that out in the Midwest. So here down in San Diego, this is a screenshot of the California Real-Time Network, and it's if you Google CRTN space GPS, you'll find this website. I should have provided a link to it, but I'll give it to you in my follow-up article, and I've published it before. But here's just a snapshot of the RTK bases down in the Southern California area. I think the far north point here is probably near LA, and this is the Mexican border, about 3/4 of the way down the screen. So San Diego's down there on the lower left. So in fact, that blue dot on the lower left, the furthest lower left, is the one we used. That was right near San Diego, and this next slide that I show actually focuses in on that. And so it just shows you that's where the RTK base was, down there on the point, right on the Pacific Ocean. And then that red X is the San Diego Convention Center, and that distance there was about 5 miles, maybe 5.5, somewhere around there. But again, we just got out. We walked over from the convention center out in open park, turned on the RTK receiver, had an iPad right there, typed in the credentials that I posted before, the IP address, port number, login password, picked this particular base, and I'd say within 15 seconds we were getting a fixed solution. And it was pretty slick, and we had it running in ArcGIS Collector, and I forget what else we had down there for data collection software. So this is an example of a RTK network. Okay, so all these RTK bases. This is the state of Washington. This is a dated slide, so it's maybe a little bit different today. But these, you can see how all these things are networked together. All the RTK bases are networked together. And we actually dial into this network. You see a list of mount points, and I think I've got a slide here in a second that's going to show that. Yeah, I've got the next slide actually. So you dial into it. Again, you see an IP address, a port number. I blanked out the user and password, but you have to enter that user and password. And then under that sources table is a list of bases, and you can see by the scroll bar that this is only a partial list, but this is the one I use. This is actually near my office. I'm in Northern Oregon, so I'm right on the border of this network. But I picked that Southwest Washington VRS RTCM3. That's my mount point that I picked because I want RTCM3 format. I don't want a proprietary format. So once I click on that SWWAVRS RTCM3 mount point, then tap on connect. You see that connect in the lower left corner. That'll connect me to that particular mount point, and again, I'll get RTK a fixed solution within tens of seconds. And I thought I had another slide in here. I guess I don't. Oh, the single base. Yeah, I think, and I'll display this one again. So this slide I displayed a little bit earlier. These are actually single bases, and this is the difference here. Is that in that previous slide where I showed the Washington reference network, those are all networked together. They're all talking to each other. They're sending their information back to a server, and it's doing some data manipulation. So they're all talking to each other. In this particular slide, the California reference network, these are all individual RTK bases. They're not talking to each other. So it's up to you as a user to find the closest one to you. And again, all I did down in San Diego was bring up this map, find the closest RTK base to me, and then I could pick the mount point. It was P475. That was the name of the station, and that's the one I used. So I guess the question might be, how far away from the base could I be? Well, your accuracy degrades with distance from the base. That's one consideration, certainly. But I've gone out as far as 20 miles and not had any problems, and I've heard of people going even further than that. So it's a matter of finding the bases closest to you first, and then going from there. But with RTK networks, since these bases are talking to each other, distance to the base is really a non-factor. You just you pick the mount point for the region that you're in, and it will optimize the solution based on multiple bases. So this this next slide is, okay, what happens if you don't have any RTK bases local to you and you want to set up your own? And I did this earlier this year, actually. And again, the same components are needed. You need, an RTK base receiver, a basic computer to run the NTRIP or DIP server software. But some RTK receivers have this NTRIP or DIP capability built inside them, and I've done it both ways. A reliable internet connection, and then an optional network switch or router, and you need, of course, some power. And then here's a picture of this next slide here. And I know this may be hard to look at. And this is sort of a system that I cobbled together earlier this year. And this picture is actually before I cleaned up the cabling and such, or should have if I didn't. So, but I just wanted to show you that the different components. This box is basically a weatherproof enclosure. It's about 14 inches by 12, I think. But here are the pieces inside. And the really important pieces are on the left part of this screen. So I have an RTK receiver. This is a pretty small one. And I have that white sort of hot dog looking thing is a Wi-Fi hotspot that I set up because we wanted to be able to broadcast via Wi-Fi also. And then with a little Intel Cube computer, which I wrote an article about a couple of months ago, really neat thing, only probably 4 inches by 4 inches, very, very small. It's just a computer. It's a regular Windows-based computer. It doesn't have to have a screen or a keyboard because you just dial into it via internet and you use Microsoft Remote Desktop to tie into it. But it's running the server software that's serving up the RTK corrections to the outside world. And then the right side is all the internet stuff, the network switch on the lower right side. There's a router in there, which we ended up not using on that site. And then that thing right there in the middle is just a power strip that we plug everything into to get it working. So the only thing feeding into this box was an internet connection. We had a LAN connection, and then power. And then the cables going out the top were just antennas, the Wi-Fi antenna and the GNSS antenna on the roof. Pretty slick solution, though. I mean, it was sort of quick and dirty, but really, really reliable. It's been running for probably, I don't know, a few months now, and a couple of hiccups, but nothing major. But really delivering solid RTK corrections via both Wi-Fi hotspot and over the internet, so you could do it either way, because the folks who I set this up for wanted to use it around their office, and Wi-Fi is super easy around the office. And it's available on every mobile device has got a hotspot on it. So that's the end of the presentation, and I know we've got some some audience Q&A, and I think Tracy, do you want to give me some of the questions there, and we can sort of talk about those a bit?
Yeah, one participant asked the following. He said, I heard from a surveying company CEO that current receiver cost is not the issue so much as performance. It doesn't work well in urban canopy areas. Does this sound right to you? If so, who do you think will be the biggest user of these smaller and cheaper, yet possibly performance-degraded solutions, at least in the short term?
Yeah, and there's a good question. I talked to a company who actually deploys lots and lots of RTK receivers, and he made the same point. He said, look, I buy the quote-unquote the best stuff out there, and I pay a premium for it because it performs better. And when I talk about having 50 or 60 crews out in the field, that time savings of having faster initialization times or whatever pays for itself over time. And so he was saying the capital equipment cost is less of a concern than the performance of the receiver. And I understand that. I get that. And I guess it depends on what your goal is. I've deployed, sort of less expensive and maybe even less accurate. But when you start talking about less accurate, do you really care if you get into centimeter or 2 centimeters or 2.5 centimeters? Yeah, maybe if you're a surveyor doing boundary stuff, but if you're a utility company taking the centers of manhole covers, yeah, maybe not. Now, vertical is a different story because vertical is tougher to get to, and maybe that's a different consideration. But it really depends on what your application is and really what your budget is too, because especially these days, there's a lot of competition in the RTK receiver world, and you can pay $25,000 for a single RTK rover, and you can pay $6,000 for an RTK rover with very, very accurate, very similar accuracy specs. So at the end of the day, it really depends on what your requirements are, possibly what kind of support is available from your local dealer. If you're not a tech person, you want lots of local support, then that's going to be a huge factor for you, is finding somebody local who can support you. For me, it's not so much of an issue because I'm pretty familiar with this technology, and so I can support myself. But for a lot of folks, they want that local support from a local dealer and that local expertise, and so it's important. So, but I think certainly there'll be less and less expensive or more inexpensive RTK devices coming on the market. There are, I know of some that will come out in the next few months, and really, really inexpensive one comes out in the next 2 or 3 years. And will they be as good as the top mainstream suppliers or manufacturers today? Probably not. But at what point is it good enough? And if the price difference is that significant, maybe 10 to 1, it really makes you think about the direction you might want to go.
Okay, and another question. What level of positional precision can be obtained and consistently maintained under typical field survey conditions and canopy, and what functional requirements need to be met in order to maintain said positional precision, such as plus or minus 0.2 feet with constant internet connectivity?
Yeah, so if we ignore the internet connectivity thing, we just assume we're getting that, right? So I think the real question comes down to, how does RTK perform in real conditions? And that means dealing with tree canopy, that means dealing with buildings, rugged terrain. RTK is, in my opinion, is still a crapshoot in those environments. You really got to be careful, especially underneath trees. I mean, and I'm as guilty of this as most people. As I did a lot of work on golf courses, or I've done a lot of work on them, and invariably there's tons of sprinkler heads underneath trees right at the edge of the fairway, and you always want to try to get those. And so you've done this before if you've worked RTK. You stand out in the open, and then you get a fixed solution, and you sort of run underneath and try to snag it as quick as you can. But it's a dangerous practice because you don't know what kind of solution you're going to get sometimes. And so under tree canopy, all I can tell you is repeatability. If you think you have a good solution, I'd take 2 more shots and compare them. And that includes walking away 30 feet, dumping the antenna, having it initialize again, going back to the point, and taking that shot again, and then comparing 3 results. If you're working in marginal conditions, I think that's your due diligence, is you've got to do that. Because if you just trust one position that you've gotten a fixed solution, the receiver could be lying to you, and I've seen it many times.
Wow. Okay. Another question has to do with purchasing. When's the right time for a purchase when things change so fast? People can no longer keep an instrument for any longer than 36 months, as some part of it or its communicating ability will become outdated.
That's a challenge. Things are changing a lot these days, and I think what it comes down to is you can't keep putting stuff off, waiting for something better to come out, because there's always something better that's going to be coming out. And you can say the same for computers, right? You can, well, should I buy a notebook computer this year or wait for next year when it's got, more features and SSD RAM and all that kind of stuff. And
you'd never buy a computer that way.
You would. You'd put it off forever, right? And so I think you can say the same thing about RTK receivers, is that, there's some, true, it's getting less expensive. So if you look around, you can find pretty inexpensive stuff out there if you want that. And I guarantee you that 2 years from now, there'll be something cheaper and smaller, and that'll be available. So it's a challenge. I think, to me, that maybe one of the bigger challenges is, Microsoft really, and I was talking about this the other day with someone else, is that Microsoft really puts us in a bind because, whenever they come out with a new operating system, that sort of is the push for new computers. Is, geez, didn't I have to upgrade AutoCAD and all this other software that I have, and it's such a pain to do that. But I was telling somebody the other day, actually the hardware of a computer that I bought 5, 6, 7, 8 years ago is still perfectly fine today, running Microsoft XP. Mm-hmm. But it's Microsoft that sort of pushes this whole thing along, and I don't know, maybe the whole Google and iOS thing will change that, I'm hoping. But it really isn't because software becomes it really isn't because hardware becomes outdated. I've got RTK equipment in my garage that still works today that I bought 15, 16, 17 years ago. That part's not the obsolete part. It's actually the data collector that's got an old version of software, and an old operating system on it. That's the hiccup part of it.
Right. Okay, another question. What are the challenges and limitations to incorporating global RTK services such as Starfire in mobile devices?
Yeah, so Starfire is a system operated by Deere, John Deere, and Navcom is actually the company. They're owned by John Deere. So they're a global satellite-based system similar to OmniStar, where they broadcast corrections via satellite. Not RTK corrections specifically, but wide area solutions. So you get down to that, 10 centimeter type of positioning. But then they mix it up with their local RTK bases to get even centimeter accuracy. And so Deere's got that kind of system. Trimble's got their OmniStar service that's very similar. There's TerraStar's service, supported by Septentrio and Altus and Novatel. And it's interesting. And actually, I think this is one of the questions that we got before the webinar, and so we actually passed it off to Navcom, and they answered it. Now let's read you the answer that they gave us. They said challenges such as integration of high quality, stable antennas in multi-frequency format, GPS, GLONASS, and so on, and also L1, L2, L5 format, and a similar high-quality embedded GPS receiver chip or GNSS receiver chip that allows multi-frequency as well as solid phase measurements present limitations to the incorporation of global RTK services into mobile devices. The challenge is the creation of small enough footprint while conserving device battery due to the fact high accuracy GNSS receivers burn a lot more power than low accuracy chipsets. I think they were answering in terms of actually embedding their kind of technology inside smartphones and tablets, and really I'm talking about having a separate receiver. And actually I've got some projects where we're using Starfire receivers with Android devices and Windows devices too, so they're actually compatible today. That answer we really focused on the challenge of integrating high RTK chipsets inside of smartphones and tablets.
All right, another question is what limitations are there with iOS and Bluetooth?
Yeah, so this is an interesting subject. So, Bluetooth is a short-range wireless, sometimes mid-range wireless connection, basically to replace cables. And typically when people talk about Bluetooth, they think, hey, as long as it's Bluetooth compatible, that means it can talk to any other Bluetooth device. And the answer is that's not the correct answer, especially in the Apple world. If you have a Windows device or an Android device, those typically are compatible with lots of different things. Apple treats it much, much differently, and we talked about this at the webinar down in Esri conference. You might want to listen to that if you're interested in this subject. But Apple requires you to have a Bluetooth authentication chip inside the peripheral. So you need to go to it. The product needs to be designed with that chip inside. It needs to be submitted to Apple for approval and certification before it's allowed to be released to the public and interface to Apple devices. And this is a huge challenge, and this is the reason that you don't see that many Apple-compatible devices, GNSS receivers especially. I mean, you see some consumer ones out there, but you don't see hardly any RTK or sub-meter type of devices that are able to interface to iOS, iPhones and.
Okay, another question. Will continued unrest in the former Russian states, I think they mean Soviet, have any future effect on the West's access to GLONASS?
Yeah, I don't think you have any problems there. I think there was that big sort of hiccup that happened a few months ago, right, where the Russians were threatening to turn off reference stations and that sort of thing. But it was just a bunch of political stuff. It really didn't mean anything at the end of the day. And so I don't think the instability over there will contribute much to the downfall of GLONASS. I mean, I think we're seeing GLONASS as strong as it's ever been. And I think also with the with Galileo and the Chinese BDS system coming online and launching new satellites, I think we're less and less exposed to any interruptions of the GLONASS system, because eventually there'll be enough satellites up there that nobody's really going to, you're not going to be worried about, in the future, you're not going to be worried about having enough satellites. There are going to be 90 or 120 satellites in orbit that you'd be able to pick from. And so I think over time this is going to become less and less of an issue.
Yeah. Okay, how does one deal with time-dependent epochs of WGS84 in regards to high accuracy?
Yeah, that's actually a huge issue now. If you want to use RTK, because then we're starting to talk about 1 to 2 centimeter accuracy. If you want to start using RTK on mobile phones and tablets, you really have to take a strong look at the software and how that software is handling datum transformations, because the position output by the RTK receiver is the datum it's referenced to is the datum that the RTK base is broadcasting. So you really have to understand what datum, horizontal datum, that RTK base is referenced to. And especially here in the U.S., most of them are set up to be referenced to NAT83, and I know that ArcGIS Online and some other services like Google Maps are all referenced to basically it's WGS84, but it's I forget what they call it, Web Mercator, I think is the word for it. And so you're going to see a shift, a 3-foot, 4-foot shift or offset between NAT83 and Web Mercator, and so people have to understand that. And in fact, I just had a phone call this morning from with an engineering company that said, "Hey, we're seeing a 3-foot offset. What's going on?" And it was purely the difference between those two datums that they were seeing. And the new pieces of software out there I mentioned before, like Collector and Esri's Collector program and Fulcrum and Amigo Cloud and others, they don't address this datum transformation issue, and they're going to need to eventually. It's going to be an issue. And the whole time dependency thing is a different subject altogether. I mean, that's, people eventually have to understand that, stuff is moving, that especially like in California, you have, the land is moving, 4 centimeters a year in some places, 5 centimeters a year. And if you're talking about using RTK that's accurate to a centimeter or 2 centimeters, and you want to go back and revisit that location 3 or 4 years later, then you really have to take into account that stuff is moving through tectonic plates.
Mm. Are we moving towards witnessing a stiff competition between the use of smartphones and tablets and GNSS receivers for mapping and related purposes, just as witnessed in digital cameras?
Yeah, I think it's a major trend. I mean, you're right. What we saw with digital cameras is, what happened to Kodak? Geez, Kodak was the king of photography for decades, right? And then all of a sudden, digital technology came around with digital cameras, and where is Kodak today? They're in a lot of trouble. And so, I think we'll see, maybe not the same transformation, but certainly I think, I've written about this quite a bit, is that RTK, it's moving more and more towards becoming sort of a commodity, just another sensor that you'll have inside your mobile phone. Like I mentioned before earlier, the gentleman down in Texas predicted RTK in your mobile phone by 2020, and that's when it becomes sort of ubiquitous technology. And then there'll be apps designed around it to exploit centimeter type of accuracy. So, maybe not the same, earth-shattering type of transformation, but certainly it's going to shake up the industry, and because RTK is going to be really, really inexpensive in the future, and the ability to get centimeter accuracy positioning will be in the hands of the masses if they choose.
All right. Next question. Would it be possible to use the internal GPS or GNSS chip of a smartphone for sub-meter level accuracy positioning using code corrections?
Yeah, I think some folks are doing it today, not with chipsets in smartphones, and I could be mistaken on that. I know some purposely designed industrial handhelds have certain chipsets inside them, more professional level kind of stuff that were designed for sub-meter accuracy. I mean, you really have to pay attention to two areas. You got to have a good chipset, a solid chipset, and then you also have to have a solid antenna, a good antenna to squeeze sub-meter accuracy, out of that kind of device. And so it's happening today already. not in mobile phones or tablets even. They're more on the purposely built handhelds that are somewhat higher priced and built for the industrial markets. I think that the challenge with smartphones is that companies like Samsung and Apple and other smartphone manufacturers, they don't see the need. They don't really care. They think, hey, as long as we get reasonable accuracy, 5-10 meters out of our receiver inside our phone, people are going to be happy with that. So there's no energy or effort or motivation for them to try to eke more accuracy out of the GNSS chip inside the mobile phone. That's going to be a challenge, I think, and I don't think they'll see the light of that for many years. I don't think they'll put the energy into it.
All right, thank you, Eric. That's all the questions we have time for, so I'm handing it back off to Joelle to close up.
Thanks, Tracy, and thanks, Eric, for speaking. And thanks to everyone for attending our RTK on your smartphone or tablet webinar presented by GPS World Magazine and our sponsor, NavCom. A recording of this webinar will be posted on the GPS World website at gpsworld.com/webinars. And it will also be emailed to you tomorrow. Please visit our website for future events like this one. Thank you for attending and have a nice afternoon.